The statement that touching only one conductor at a time will prevent electrical shock isn't correct. Touching a single live conductor, even with an ungrounded body, can create a path for current to flow through you to Earth, resulting in an electrical shock. Always wear appropriate personal protective equipment, or PPE, including hot gloves and leather gloves, when working with live electrical components. When making service connections at the Weatherhead, there are several types of service connectors you should be familiar with. Firstly, mechanical lug connectors are used to connect service wires to the Weatherhead. Secondly, split bolt connectors are used to connect multiple service wires together. Thirdly, underground service entrance or use connectors are specifically designed for connecting service wires to underground conduits. Here is the procedure for making service connections. 1. Prepare the service wires by stripping approximately 12 inches of insulation from the ends of the service wires. 2. Attach the mechanical lug connectors by crimping mechanical lug connectors onto the stripped ends of the service wires. 3. Connect to the Weatherhead by inserting the lug connectors into the appropriate terminals on the Weatherhead. 4. Tighten the terminals using a torque wrench or a lineman's wrench, and tighten the terminal screws to the manufacturer's specifications. 5. Connect the neutrals by connecting the neutral service wire to the neutral terminal on the Weatherhead. 6. Connect the grounds by connecting the ground service wire to the ground terminal on the Weatherhead. 7. Insulate the connections by covering any exposed live terminals with electrical tape or heat shrink tubing. Here are some safety tips to keep in mind. Firstly, ensure that the power to the service is turned off at the main breaker or disconnect before performing any connections. Secondly, always verify that the conductors are de-energized using a voltage tester before touching them. Thirdly, use insulated tools and a non-conductive ladder or platform when working on live equipment. Fourthly, be aware of your surroundings and maintain a safe working distance from live wires. As additional tips, firstly, if you are not comfortable making the service connections live, you can hire a licensed electrician to perform the work. Secondly, consult the manufacturer's instructions for specific guidelines on making connections for the type of Weatherhead you are using. Thirdly, practice making connections on the energized equipment before attempting live work. Electrical safety is paramount when working with electrical systems. Understanding the dangers of electricity and adhering to safety protocols is crucial to prevent injuries and ensure a safe working environment. One of the most fundamental concepts in electrical safety is understanding how electric shock occurs. Electric shock happens when a person becomes part of an electrical circuit, allowing current to flow through their body. This can occur in several ways, such as touching a live wire while being grounded or coming into contact with faulty equipment. The severity of the shock depends on factors like the amount of current, the path it takes through the body, and the duration of exposure. To mitigate the risk of electrical shock, it's essential to wear appropriate personal protective equipment, or PPE. This includes insulated gloves, safety glasses, and flame-resistant clothing. Insulated gloves, also known as hot gloves, are specifically designed to protect against electric shock when working with live electrical components. These gloves are made of rubber or other insulating materials that prevent current from flowing through the hands and body. Safety glasses protect the eyes from sparks, arcs, and other hazards that can occur during electrical work. Flame-resistant clothing provides an additional layer of protection against burns and other injuries caused by electrical arcs and flames. Lockout-tagout, or LOTO, procedures are another critical aspect of electrical safety. LOTO involves disconnecting and isolating electrical equipment from its power source before performing any maintenance or repairs. This prevents accidental energization of the equipment, which could result in serious injury or death. The LOTO procedure typically involves several steps, including identifying the energy source, disconnecting the power supply, locking out the disconnect switch, tagging the disconnect switch with a warning label, and verifying that the equipment is de-energized before starting work. Grounding is another essential concept in electrical safety. Grounding provides a low-resistance path for fault current to flow back to the source, tripping a circuit breaker or fuse and de-energizing the circuit. This helps to protect people from electric shock and prevent equipment damage. Grounding systems typically consist of grounding conductors, grounding electrodes, and bonding connections. Grounding conductors connect the electrical equipment to the grounding electrode, which is a metal rod or plate buried in the earth. Bonding connections connect metal parts of the electrical system together, ensuring that they are at the same electrical potential. Arc flash is a dangerous phenomenon that can occur when a high-voltage electrical arc forms between conductors. Arc flash can generate intense heat, pressure, and light, causing severe burns, injuries, and even death. To protect against arc flash hazards, it's essential to wear appropriate arc-rated PPE such as arc flash suits, helmets, and gloves. Arc flash suits are made of flame-resistant materials that can withstand the intense heat of an arc flash. Arc flash helmets provide head and face protection from burns, impact, and projectiles. Arc flash gloves protect the hands from burns and electrical shock. Regular inspections and maintenance of electrical equipment are crucial for preventing electrical hazards. Inspections should be conducted to identify any signs of damage, wear, or corrosion that could lead to electrical failures. Maintenance should be performed to repair or replace any damaged or worn components. Regular testing of electrical equipment, such as circuit breakers and ground fault circuit interrupters, or GFCIs, is also essential to ensure that they are functioning properly. GFCI devices are designed to protect against electric shock by quickly interrupting the circuit when a ground fault is detected. Electrical safety training is essential for all workers who may be exposed to electrical hazards. Training should cover topics such as electrical safety fundamentals, PPE requirements, low-tow procedures, grounding principles, arc flash hazards, and emergency response procedures. Training should be conducted by qualified instructors and should be tailored to the specific hazards and equipment that workers may encounter. Electrical codes and standards provide guidance on safe electrical practices and equipment design. These codes and standards are developed by organizations such as the National Fire Protection Association, or NFPA, the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. Following electrical codes and standards is essential for ensuring that electrical systems are designed, installed, and maintained in a safe manner. Electrical safety is not just a matter of following rules and regulations. It's also a matter of developing a safety culture in the workplace. A safety culture is one in which safety is valued and prioritized at all levels of the organization. In a safety culture, workers are encouraged to identify and report hazards, and management is committed to providing the resources and support necessary to address those hazards. Creating a safety culture requires leadership commitment, employee involvement, and continuous improvement. By fostering a safety culture, organizations can create a safer working environment for all employees. Specific types of service connectors are essential for making reliable and safe electrical connections in various applications. Different connector types are designed to accommodate different wire sizes, materials, and environmental conditions. Using the correct connector for the job is crucial to ensure a secure and long-lasting electrical connection. Mechanical lug connectors are widely used for connecting conductors to equipment terminals, bus bars, and other electrical components. These connectors typically consist of a metal body with a set screw or compression mechanism that secures the conductor in place. Mechanical lug connectors are available in a variety of sizes and materials to accommodate different wire gauges and conductor types. Split bolt connectors are commonly used for splicing or tapping conductors in electrical systems. These connectors consist of two halves that are bolted together, clamping the conductors between them. Split bolt connectors are typically made of copper or aluminum and are available in a range of sizes to accommodate different wire gauges. Underground service entrance or use connectors are specifically designed for connecting underground service entrance cables to electrical equipment. These connectors are typically watertight and corrosion resistant to withstand the harsh conditions of underground environments. Use connectors are available in various configurations, including straight, angled, and T-shaped to accommodate different installation requirements. Compression connectors are used for making permanent electrical connections by compressing the connector onto the conductor. These connectors are typically made of copper or aluminum and are available in a variety of styles, including butt connectors, parallel connectors, and terminal connectors. Compression connectors require the use of a specialized crimping tool to ensure proper and secure connection. Insulation displacement connectors, or IDCs, are used for making quick and easy electrical connections without stripping the insulation from the conductor. These connectors consist of a plastic housing with sharp metal contacts that pierce the insulation and make contact with the conductor. IDC are commonly used in low-voltage applications such as telephone and data cabling. Wire nuts are used for connecting two or more conductors together in a junction box or electrical enclosure. These connectors consist of a plastic cap with a tapered internal thread that screws onto the conductors, twisting them together and creating a secure connection. Wire nuts are available in various sizes and colors to accommodate different wire gauges and applications. Selecting the right service connector for a specific application requires careful consideration of several factors. These factors include the wire gauge, conductor material, voltage rating, environmental conditions, and applicable electrical codes and standards. It's essential to consult the manufacturer's specifications and instructions to ensure that the connector is suitable for the intended application. Proper installation techniques are also crucial for ensuring a reliable and safe electrical connection. These techniques include stripping the insulation from the conductor to the correct length, cleaning the conductor to remove any dirt or corrosion, inserting the conductor into the connector to the proper depth, and tightening the connector to the specified torque. Following these best practices will help to prevent loose connections, overheating, and other electrical hazards. Regular inspection and maintenance of service connectors are essential for ensuring their continued reliability and safety. Inspections should be conducted to identify any signs of damage, corrosion, or loose connections. Maintenance should be performed to repair or replace any damaged or worn connectors. Regular cleaning of connectors can also help to prevent corrosion and ensure a good electrical connection. Safety precautions should always be followed when working with electrical connectors. This includes energizing the circuit before making any connections, wearing appropriate personal protective equipment such as insulated gloves and safety glasses, and using insulated tools. It's also essential to follow all applicable electrical codes and standards to ensure that the electrical work is performed in a safe and compliant manner. Proper torque is crucial when tightening service connectors to ensure a secure and reliable electrical connection. Over-tightening or under-tightening a connector can lead to various problems, such as stripped threads, damaged conductors, and loose connections. To ensure proper torque, it's essential to use a calibrated torque wrench and follow the manufacturer's specifications. Torque specifications are typically provided in inch-pounds or foot-pounds and should be carefully followed to achieve the correct level of tightness. Over-tightening a connector can damage the threads or the conductor, leading to a weakened connection. Under-tightening a connector can result in a loose connection, which can cause overheating, voltage drops, and even electrical fires. Using a torque wrench allows you to apply the correct amount of force to the connector, ensuring that it is properly tightened without being over-tightened or under-tightened. Calibrating your torque wrench regularly is also essential to ensure its accuracy. Torque wrenches should be calibrated at least once a year or more frequently if they are used heavily. Calibration involves comparing the torque wrench's readings to a known standard and adjusting the wrench as necessary to ensure that it is providing accurate readings. Using a properly calibrated torque wrench is a simple but effective way to improve the reliability and safety of electrical connections. By following the manufacturer's torque specifications and using a calibrated torque wrench, you can ensure that connectors are properly tightened and that electrical connections are secure and reliable. In addition to torque, other factors can also affect the reliability of electrical connections. These factors include the cleanliness of the conductor, the type of connector used, and the environmental conditions. Before making an electrical connection, it's essential to clean the conductor to remove any dirt, corrosion, or other contaminants. A clean conductor will ensure a good electrical contact and prevent overheating. The type of connector used can also affect the reliability of the connection. Different connectors are designed for different applications and wire types. It's important to select the correct connector for the job to ensure a secure and reliable connection. Environmental conditions can also play a role in the reliability of electrical connections. Connectors that are exposed to moisture, corrosion, or extreme temperatures may be more likely to fail. In these cases, it's important to use connectors that are specifically designed for those conditions. The National Electrical Code, or NEC, provides guidelines for the proper installation and maintenance of electrical systems. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Following the NEC is essential for ensuring that electrical systems are installed and maintained in a safe and compliant manner. The NEC is updated every 3 years to reflect changes in technology and industry best practices. It's important to stay up to date on the latest edition of the NEC to ensure that your electrical work complies with the current requirements. The NEC is not a substitute for proper training and experience. Electrical work should always be performed by qualified individuals who have the knowledge and skills necessary to do the job safely and effectively. Electrical safety is a shared responsibility. Everyone who works with or around electricity has a responsibility to follow safe practices and procedures. By working together, we can create a safer environment for ourselves and others. Remember to always prioritize safety when working with electricity.